Hi, I'm Daniel. I'm here from the city of Chattanooga. Can you hear me in the back? Okay, great. And I'm here today to talk to you about a flood map, how we built a near real-time map of reported flooding and road closures for Hurricane Helen. Simple agenda here, what we built, how we built it, and a lot of lessons learned. But it started with a question, what if? 2 days before Hurricane Helen hit Chattanooga, my boss, the head of the Innovation Delivery and Performance Department, Tim Moreland, he came to me and asked me a question, what if we could create a real-time map of flooding? And I said, I have no idea, but let's give it a go. Okay, so what did we build? It's really quite a simple map, intentionally so. It was a map of where there's flooding and where there's road closures. So the circles on the map there, that is where there's reported flooding. And then the lines are where the road is blocked. And I'm not a designer, so it could have definitely looked better, but love that blue. We also had pop-ups giving more information, and so this one is talking about more details about the road that was closed. We were moving really fast, building this really cool map, but our city content management system isn't really a geospatial platform. It's meant for something different. And so the way we kind of built that bridge connected to the citizens online was through just adding a simple link to the city website, and then that brought them to the map. I wanted to spend a minute to talk about the differences between reported versus predicted flooding. Predicting where flooding is going to be is a lot harder. We didn't do that. I bet there's a few of you in the room who, or maybe more than a few actually, who know about hydrological modeling and flood modeling, and those are really cool people, and you should talk to them. I am not a flood modeler, so that's not what we did. We didn't map where we thought there was flooding. We mapped where people reported there was flooding. And there's some nuances there, of course. From what I've heard from our folks at Stormwater, that sometimes flooding can happen even if the model doesn't predict it. At an intersection, maybe there is a lot of tree pollen, or there's just some mattress in the road or something, or a tree fell down. That can block the flow of water and lead to sort of short flooding in intersections, which are very important to cars, but it's not something that you can predict from a model. And so they both work hand in hand, but we're really just talking about reported flooding. So how did we build it? Humans and technology. They were both equally and both incredibly important to this. It wouldn't have worked without either of those. And here's a map of our data journey. Are y'all able to see that? Is that kind of? Okay. We'll have those slides out later too. But in the middle there, in that big rectangle, is the flood map. And data came from a bunch of different places. Oh. In green, those are all people. So data didn't get onto the map without people. It started with people. And so in the top left, you see our great head of public works, who really added extra work to his plate on top of his busy day to send us emails from the Emergency Operations Center letting us know where flooding was happening when he got reports. In the bottom left, you see a citizen who is contributing to their community in calling our 311 service center to report flooding at an intersection or in their neighborhood. And then at the far right, you have citizens who are calling 911 to report flooding. It all starts with people. GitHub Actions played a very critical role. And if you want to learn more about GitHub Actions, we have a workshop tomorrow. And if it is sold out, reach out to us. All the material's public, and we're happy to do an online workshop sometime too. Oh, and just wanted to give a shout out to GDAL, I say GDAL, and then OpenStreetMap. Great tools and data sources. Okay, logo bingo. Does anyone here think they can get all, what's that, 7? The highest, the record right now is 6. Does anyone in the room think they can get 6? 5? Raise your hand if you can. Who can get 5? Okay, over there.
So Python, GitHub, Chattanooga, StreetMap, Google Maps, JavaScript?
Google Maps. Oh, wow, you got the Google Maps one. That was the trick question, yeah. And so then okay, so the bottom left is Tyler Tech. They're a proprietary company, and that's our data platform is our data warehouse is them. And then the top right is Map Libre. And the circle, I don't know if I said this, that's Safe FME Workbench. And are they here today? Someone from Safe, raise your hand. Okay, but they're really cool. So check their stuff out too. Man, the Google Maps one, no one gets that one. Okay. Okay, you can't replace humans. None of this works without humans. Oh, and then, sorry. Technology can be a crutch too. I've spent years trying to use AI to scrape Twitter feeds to identify flooding, and it's really interesting work and can be complementary, but sometimes you just need someone to pick up the phone when a citizen calls. Just have someone there to take down information. It doesn't have to be AI. You just need to empower a service center of great employees. Oh, just kind of. How much time do I have left? 2 minutes. Okay, preparation is key. Start building those data pipes today. Culture matters. Risk-taking is important. This was all very risky for us, and we didn't know if it was going to work. But it did, and we were able to take that risk because we had psychological safety. And we also knew we weren't going to make it public unless it was working. Decision to delivery, it's really important, the timeline, how much time it takes from having a decision to do something to delivering it. For us, it was 2 days. But if we only needed 2 sign-offs to make it happen. For a lot of you in the room, decision and delivery is probably a longer road. So when you add more sign-offs, it slows things down. Capability perspective. Okay, so this is probably the most controversial one, and I might spend the most time on this one. We approach things in my office from a capability perspective. We are trying to basically build our data muscles and to build our abilities to do things as a city. That includes automating pulling from Google Maps and just general geospatial capabilities and data capabilities. When you have this perspective, what that means is that sometimes you do want to take longer to do something if you're going to learn from it. You don't necessarily, if you can take 4 days instead of 2 days to do something, but it unlocks a new ability, sometimes if it's not an emergency, it's worth taking that time, because then you can use that capability later. And so we had been building our capabilities for a while, and it did take a long time to figure out how to automate pulling from a Google map of road closures through GitHub Actions onto our open data platform, but we had unlocked that previously. Open data leads to faster delivery. You don't have to worry about passwords or authentication. That's really helpful. Open source leads to faster delivery. Has anyone ever in this room had to deal with ArcGIS licensing issues? All right, I'm not seeing any hands, but open source leads to faster delivery. But the big takeaway here is proprietary and open source can work together. It's not a all or nothing choice. We use proprietary, we use open source, and you can start your open source journey today. Thank you.